Diagram 2 shows two straight lines L1 and L2 drawn based on 5 plotted points on a plane 1 over y against x squared. For part A, the question asking us which straight line is a suitable line of best fit. Give a reason for your answer. Now try to observe on these two straight line L1 and L2. Now we look at L2 first. You will notice that L2 passes through 2 points and 1 above, 2 below, right? Whereas for L1, also the same thing, passes through 2 points, 2 above, 1 below. But you will notice that the points which are not on the line drawn, for L1, they are actually closer to the line drawn, right? Compared with L2, this is quite far away compared with this one. So in this situation, we can make a conclusion that L1 is a better line of best fit, or you can just follow the questions. L1 is a suitable line of best fit. Both L1 and L2 pass through 2 points. But for L1, the remaining point, or you can say the point which are not on the straight line, are closer to it. Okay, so this is the answer for part A. You can use your own sentence. Now how about part B? Given that 10, 9 lies on the line of best fit, express y in terms of x. So we want to make the y as a subject. Y equal to mx plus c. In this situation, the big Y here is actually 1 over y. And the big X here is actually x squared. So the m is a gradient of this straight line. So we cannot use 2, 4 because 2, 4 is not on the line. So we can use 6, 7, and another point is 10, 9. So given by the questions, 10, 9 is on this straight line. Okay, I just label it here, 10, 9. Okay, so since these two lines are these 2 points are on this line of best fit, we can use them to help us find the gradient of this line. So just use a formula for finding the gradient of a straight line, y2 minus y1 and x2 minus x1. So this will give us 2 over 4, which is equal to 1 over 2. Okay, just plug in here. 1 over 2 x squared plus c. The next thing that we need to do is to find the value of c. So we can use this point or this point, both are okay. You will get exactly the same answer. But you need to be more careful. The 6 here is actually not x, but x squared. The 7 here is not y, but 1 over y. Okay, this 6 here is x squared, 7 is 1 over y. Same thing apply here. If let's say you are using this point, the 10 is actually x squared, and the 9 is 1 over y. Okay, let me use this point. At point 10, 9, so be careful. This is x squared, and this is 1 over y. So if you do this way, which is not correct, 1 over 9 is equal to 1 over 2 times 10 squared plus c. This is incorrect. What we should do is just replace the 1 over y by this and replace the x squared by this. Okay, 1 over 2 times 10, you will get 5. 9 is equal to 5 plus c. So c is equal to 9 minus 5, which is equal to 4. Okay, now we got the equation. 1 over 9 is equal to 1 over 2 times x squared plus 4. But we cannot stop here because we want to express y in terms of x. We need to make the y as a subject. So this is actually 4 over 1. So what I'm going to do is times 2 times 2 so that this both term having the same denominator, then I can combine them together. So 1 over 2 times x squared, you can write them as 1 x squared over 2, it's the same thing. Okay, now they have the same denominator. I can combine these two fractions together, become x squared plus 8 over 2. Why do I want to combine them together? Because after combining these two fractions together, it become one terms. Now I can just flip over the numerator and denominator, do the same thing for both sides. So I will get y over 1 and 2 over x squared plus 8. Y over 1 is actually equal to y, right? So this is our final answer. So some students might think that why not we just do this way? For example, 1 over y is equal to x squared over 2, right? And then plus 4. Why not we just do it this way? Y over 1 is equal to 2 over x squared plus 1 over 4. This is not correct. Now let me show you. Let's say if you have let me use a very simple example. Let's say 6 is equal to 4 plus 2. Do you agree? Yes, right? This is correct, right? So 6 is actually 6 over 1. Let me write again. Rewrite the equation again. So 6 over 1 is equal to 4 over 1 plus 2 over 1, right? So if you do this, you will get 1 over 6 is equal to 1 over 4 plus 1 over 2, which is not correct. You can press your calculator. 1 over 4 plus 1 over 2 is actually not equal to 1 over 6. This is not correct. But if you do it this way, now you combine these two together, you become 6 over 1 is equal to 4. This is 4 over 1 plus 2 over 1, right? You can combine them together, become like this. It's actually the same thing, right? Same because this is 4 over 1, 2 over 1, they're having the same denominator. You can just combine them together. Now, 1 over 6 is equal to 1 over 4 plus 2. Is this correct? Yes, this is correct. So this is the reason why I want to change the denominator become the same first, then combine them become one terms, then only I flip over the numerator and denominator for the both sides. Okay, so this is the answer for part B.